There we go.
Did you have any questions with the homework, or did you?
I think I got it. The only question I had was number 6, X bar. Was there anything that said anything about X bar?
I think it did in the reading. I'll pull up my book.
Yeah, I didn't catch that phrasing, and so I was wondering what I missed. And granted, I did just finish reading it. But other than means and standard means and sample means and deviations and sample deviations, I didn't see the terminology X bar.
I'm still looking for it. I know it was in there. I remember seeing it. Let's see if I can Control F, find it faster than scrolling around in here.
That's a trick that you know that I don't know.
My kids taught me. It pays to have teenagers who are.
Control F is a search.
Yeah, Control F will search a page for like a word or a phrase. I know I saw it somewhere. I'm not finding it in the reading. Maybe it was in the reading.
How did you answer that question?
Oh, let's see. Yes.
And did you get his email letting you know you got 100%?
No, I haven't looked.
You took the test for both of us because he did want us to take it together because he only wanted to grade 1 submission. But
right.
You did great. You got 100%.
Oh, well, good. I haven't even looked at it. That must have just recently popped up because I've been doing homework all day.
Yeah.
It would have been a bit of a blur. But, okay, here it is. I'll find it.
Yeah, it seemed like all I'm reading about is means and deviations and distributions.
Well, it was talking about the central theorem and the law of large numbers, and
right.
Was in that part of it.
I just didn't want to be missing because that didn't hit me. So
I'm going to skip over that one because now I'm not sure. Sample X.
I'm wondering if what it's referring to as X bar is the mean with the bar over it.
Well, because that's what you don't see the sample mean with the X with the slash over it for particular
right.
sample.
So maybe that's what this is referring to, and it's just writing it.
I'll make a note of that and I'll email him with that question just to be safe.
Yeah, when is the sample? I bet X bar is written to resemble sample mean.
Right.
So when is the sample mean normally distributed? Okay, that makes sense. Alrighty, so part 2.
We're supposed to go over. I wasn't about to cut up all those little squares.
No,
so I used their little randomizer.
Yeah, I did too.
Okay, so my mean that I came up with from the numbers it gave me was 44,500.
Okay, hold on just a minute. So Because I didn't do the second half here. I did the first half.
Oh,
Um,
it was pretty
so we
straightforward. You just take your, they had the link in there for the randomizer link to
right.
randomly pick from some of those quadrants and then find the mean from whichever ones. And then we're just supposed to compare on the graph to see if we were within a reasonable frame or if there were any outliers from the graph.
Okay,
And
and
so
so where did
mine
you?
ended up being 44,500, which was pretty close to, it was right in the thick of it, within 68%, looked like.
Okay, so just so that I understand that correctly, so we just take. So I took the 5 random ones that I have, and basically add them up and divide them by 5, right?
Right.
And that gives
Yeah.
us the. Okay. So let me just do that real quick. I've been giving great consideration to dropping this semester, and I'm really torn.
I know I had my email pop up today, like today was the last day to drop a class without losing full value or whatever. Boy, that was tempting.
Yeah, and but it kills me because, I'm doing okay in classes right now, but I'm really struggling between managing my daughter. Like I scrambled to get home to read this, be prepared for tonight. Okay, so mine was 46,820.
So yours was even closer to the mean. And so it's the question on 7C was, does your sample mean appear to be unusual? No. And explain why you think it is or isn't. And it's close to, looks like within one standard deviation.
Okay.
So that was my assumption that the majority of any numbers we'd pick would be
Would
within
be
the normal
with,
curve.
okay. Let's see, compare your mean from question 7A to the means obtained by at least 3 other individuals. Well, we only have 2 of us. And
Yeah.
what was yours?
So mine was right there too.
Okay. And the graduate management admission test is used as an admission criteria for many MBAs. The scores on the GMAT are normally distributed with a mean of 529 and deviation of 113. Consider a simple random sample with the number of 10 taking the GMAT. What is the shape of the distribution of sample means for all such samples? So the distribution would be normal, wouldn't it?
Mm-hmm. And then the question of how do you know the distribution of the sample mean has this shape? And the parent population is normally distributed. So when they give you that answer, it means that
Yeah. Then the distribution of the sample means it's going to be
right.
normally distributed.
Okay.
Parent. Yeah.
And then like on D, that one seems like a formula we'll probably definitely need to use about finding the standard deviation as far as taking your standard deviation and dividing it by the
Square root
root.
of
The
the
root.
population.
Yeah.
Okay, so we have the standard deviation for this was 113. And we would divide that by the square root of 10 because that was the population, right?
Right.
Okay, let me. So
I
square
did it
root
earlier, but I'll do it again.
of 10. So the square root of 10 is 3.162. So
113 divided by that.
113 divided by 162 equals 35.737 if you round it.
Yeah, 7337. So, yeah, it depends on how many places they want it. But.
So 35.737.
I had 35.7337. I know their answer is 35.734, so I think they just they rounded it up to
I
0.73.
wonder if my square root was off. Okay, because I'm not anywhere close to 7. Well, I guess 7. Because my calculation came out to 35.73687. So I wouldn't have gotten 334. I'll redo my math but I won't do it now. I'll go back and redo it.
I think it helps. There was one class that I had to take early on that they said it does help to learn to use your calculator the way the formula is written, like using your brackets and that, because it can make, a 1,000th of a difference in the rounding ups and such. I know for me, I had to get used to cleaning that up.
3.1622. Wait a minute. Let me go equal. No, shoot. Let me just try that one more time.
So I go 113 divided by parentheses 10 square root parentheses equals, and you should get it.
35.73. Yeah. Yeah.
Does that make sense?
4. Yeah.
Yeah.
Interesting. I will have to do that. Okay, 734. Okay. And then the last question is, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? Okay, hold on a second here. Didn't we just figure that out?
Yeah, we skipped to D, I guess, and we skipped C. What is the mean of the, so if we go back up to C, what is the mean of the sampling distribution of sample mean scores?
The mean would be the same.
Yeah,
right?
It's the same thing that they already gave you. They give you the mean.
Right.
I don't know why. It kind of felt like I had to go check my answer because I thought, is this a trick question? Because it's just the mean. They already gave it to me.
The mean is 529, right?
Right.
Okay. And then the sample deviation is what we just figured out.
Is what we just figured out.
735.734. Okay. Alrighty. So then we ready?
You bet. Alright, get to it.
Get to it.
Okay, I'll click start.
Start.
Okay, number 3.
Yes. I actively participated. Okay. When taking samples of n, when n is equal to 5, what was the shape of the distribution of means histogram when the population is right skewed?
That was that link that we followed on the histogram, and it was skewed right.
Okay, so let's take a quick look at that. What did it say? It's like, hold on a second, let me close this.
Gotta find it, wherever it was at.
Yeah, let's see.
It was skewed though, I remember that.
Okay, when taking samples, when N5, what was the shape of the distribution? Okay, so we do 5. And did it say it was a normal distribution? When the parent population right skewed. Okay, right skewed. Normal skewed. 5.
Skewed right?
Hold on a second. Let me clear that and start that again. Yeah, skewed right
Okay.
when you repeat it. When taking samples of N100, so that means it's a large sample.
A large sample, not a small one.
Right. What was the shape of the distribution mean histogram of the population? It would be normal, wouldn't it?
Yeah,
Large population. So let's try that out.
normal.
Yeah.
Okay, and then when taking samples
Sample.
of N100
So
is
large.
normally distributed.
What was the shape of the distribution means when the parent population is normally distributed? Normal.
Yep.
Wouldn't that be? Because
One-
large population means normal. Okay. When when would the distribution of means be normally
Normally distributed.
distributed? Data are
Well,
drawn from data when data are drawn from a population that is normally no, not when this is small. Data are drawn from a population that is
when it's
normally
large, that
small.
one's true.
Data are drawn from a population of right skewed and sample size is small. No, sample size is large.
It's when it's big, when you've got a large sample size, it'll give it a normal shape, right?
Well,
So
and
those,
if the data are drawn from a population that is normally distributed and the sample size is small, it's going to be normally distributed means.
so that one will be also
Yeah.
normal. Okay.
Does that make sense to you?
Yeah, I remembered it more from a larger context, but then when you did the not that link for the distribution of means, when it
Right.
had you increase it and small the histogram, it was still normal. So yeah, that makes
Right.
sense. I think the only one that it's not is the third one, the
When the
that is
population,
right skewed and sample size is small.
right, when the population is normal, then the distribution of means is always going to be normal.
Okay.
I think
Okay.
that's, I remembered that saying. Okay. So which of the following gives the best explanation of the current, of the central limit theorem? If the parent population is normally distributed, then the sample mean will follow a normal distribution. That sounds right.
It does. For
For,
bell-shaped,
you go ahead and read it.
okay, for bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean.
That's
About 95% of the data will be within two, and approximately 99.7% of the data will be within three.
yeah, that's right, but not for the central limit theorem.
Right. The sample size is large. The sample mean, there's the answer to our question, the X bar, because it has a bar over it, will be close to the population mean. No.
Okay, so hold on a second. So central limit theorem for the distribution is as the sample size becomes large, the distribution of the sample means becomes approximately normal. Okay, so if the parent population is normally just, if the sample size, okay, because I have it written down, as the sample size becomes large, the distribution of sample means becomes approximately normal. If the sample size is large,
So the the
the
bottom one, the
sample,
shape the shape of the sampling distribution of the sample mean x bar will be approximately normal.
yeah, I think you're right. That's it.
Okay. I think
Let
it's that one.
x be, yeah, I think so too. I
Mhm.
need to reread it. Let's see. If the sample size is large, the shape, which is the distribution, shape of the sampling distribution
I think
of
it
the
is that
sample
one.
mean, approximately normal. Yeah, I think so too. Let x
Okay.
be a random variable with a population mean of 10 and a population standard deviation of 6. Suppose the sample size of 36 is drawn from this population. So that means 36 is what's considered large because it's over 30.
Mm-hmm.
So what is the mean of the distribution of the sample means? So that would mean
10.
10.
Okay.
That's what I would say too.
Okay.
Mean would be the same.
Okay. What is
And
the standard deviation? So we got to figure out standard deviation.
okay, so that's going to
So
be
this one is
6 divided by
divided by
36, the square root of 36. Okay, so
1. You get 1
let me do it. Hold on a second. So I'm going to say 6 divided by
square root of 36.
1.
1.
And it says to 3 decimal places, so 1.000.
Yeah. Okay.
That's what I got. Regardless of the distribution of the population, if the sample size is large, what would be the shape distribution of the sample mean? Would
Well,
be,
that would mean it would be normal because we already answered that
yeah,
in 7, right?
right. And it would be the law of large numbers.
Right.
Is that right? Law of large
Let me read
numbers.
the central.
Accuracy. No, it's central limit theorem, I think.
Let me reread the central theorem one.
This is how I'm remembering it because they in the videos he
Yeah.
kept he kept stressing that law of large numbers was about accuracy and central limit
Oh.
theorem is about distribution and shape of distribution,
So
right?
if you know it's normal and it's about distribution, then that means it would be central limit theorem,
Yeah, I think
if that's
so.
what we're looking at.
Regardless of the distribution of the population, because it's asking about the shape of the distribution of the sample mean, and I think that's the central limit theorem
Okay, good catch.
because the law of large numbers is about being confident about the accuracy.
Okay.
So
All
I
right.
so we're going to submit.
Let's do it.
Yay!
Hey, good job.
Yay! Yay!
Well,
Okay.
that makes me feel good.
Yeah. Yeah, I know, and see, that's where it's like, okay, can I get through the next 2 weeks? Am I um, not that I want to broadcast this out, but I'm having to find another hospital for my child to stay at for a period of time. And so it's like,
Um,
can I get through the next 2 weeks of school? That would save my semester.
you know
If I,
what? You can, and you will. Last year, my mom was going through breast cancer, and she chose to have a
oh,
double mastectomy, and so I ran to her aid, and I was doing homework online, and it was so stressful. But and I was up with her at night, and it was pretty traumatic for a couple of weeks, but then it got to normal, and all the professors were more than willing to work with me. I think it
Well,
kind of helps to be a little bit older of a student in this situation because I
yeah,
think they're more understanding.
yes.
Um, so
Yeah, and
and
I will send him off an email and thank him for opening.
yeah, I am really grateful. Oh
Me
yeah, there's our grade.
Yeah,
Cool.
me
I
too.
probably spent way more time on that, but
Well,
yay.
I've got to. I have to talk quietly because I have to go through and do that one for myself so that I can go through
Yeah.
and make sure I had those answers correct.
I'm
So
gonna I'm gonna print off our quizzes and help use those as study guides along
yeah,
with
I
just
think so.
for leading up to the test.
Yeah, I think so too. I sure wish that they would give us the right answers
Afterwards,
afterwards. So because the ones he went over weren't the ones that I missed.
that I had a question on. Yeah.
And I think on
Well,
one, I think on one of them I was supposed to put it in a percentage and I put it in a decimal. So I think I know what I did wrong on that one. But it was the last question, and I was doing it in the middle of the night, and I was tired and I was emotionally exhausted, and so I was like, I finally just went, I can't think anymore. I'm just gonna submit this, and it's the lowest
yeah.
grade so far. I missed two, you know.
Sometimes you have to take a hit though, and it'll all round out. But
Oh, yeah.
can't
All
beat
right.
yourself up too much.
Well, thanks for your patience with me for not having the second half done. And
That's okay. It's
I
all right. We'll get through it, and then we'll just meet again on Friday next week. We're taking our daughter to the MTC
right,
on. We're gonna leave on Tuesday morning, so I was hoping maybe we could move that meeting up to either Monday or move. We'd have to have that one really late because I'll be pretty preoccupied Tuesday and Wednesday.
right.
I don't know if you keep that in the forefront of your mind. I'd be willing to do it super early too if it works better for you.
I might
Um,
have to do it super early because it all really depends on what happens with my daughter.
okay.
Um, she's, in fact, I'm going to be taking her out to Utah um, to a hospital that's there.
Okay.
Once she's there, she's going to be there for probably several months,
Wow.
2, 3 months, yeah.
Yeah.
Um,
Okay.
but um, so I'm kind of not knowing what my next week's going to look like either. And
Okay.
typically I work on Mondays, and so I can say, yeah, we could try it, but I could get called in and I could be there for several hours. So it's Mondays are
Okay.
just very hard for me to commit to. But let's stay flexible. You know, you have my cell, I have your cell. We'll stay in touch and
Okay.
we'll play it by ear. And I'll send you a text because um, I'll know in the next day or two, and maybe we have it Sunday night.
Yeah.
Just try
That
to
might
get
even work too.
right. Just try to get our reading done early and do it Sunday night.
Get it out
Um,
of the way.
yeah.
Yeah,
So
that might even be a good idea.
yeah. So let's just play it by ear because if I'm not working, then Monday will not be an issue. We can do it on Monday. If I'm working, it's hard for me to commit. Um, I could do it and everything could go fine, or I could say, yeah, it's looking good at 6, and my pager could go off,
Okay.
and I'm done.
All right. Well, we'll work around it. Don't stress over it. We'll just kind of have to wing it a little bit until we figure something out and get you through the next couple weeks. And for me, I just have outbursts of crying with my thinking about my daughter leaving me.
You and me both. You and me both. I woke up this morning bawling my eyes out, and I went to the hospital, and I got to her room, and I just had to walk out the door and turn around because I was crying again, and it's even now.
Um,
It's very hard to do. I just need to get through the next little bit, and then I know that she's going to be in a better place for a while. That's really going to help her, and
well, good.
And your daughter's going to be in a great place because she's doing what the Lord wants her to do.
It's definitely scary. That's for sure. As a parent, like, what am I sending her off
Yeah.
far away? But yeah, it'll be good. Well, good luck with your daughter, and then I'll just get in touch with you on Friday, and I'll pop you up to record. We'll
Okay.
see what works
Right.
best for our schedules Friday if we need to be flexible or whatever. Okay.
Alrighty. And it was a great movie I watched once that was about uh, uh, traditional Jews. What I forget
Oh.
the sect. And one of the statements that was made in the movie, this was an old movie, said that God counts all the tears of women, and so
Oh,
he knows all your tears and he counts them all. And
that's sweet. Oh,
I hope you
it's
get through.
sometimes it's harder than other times. Sometimes they're more than just tears of joy, but you'll
Yeah,
get through it. It's gonna be good. It'll be okay.
and you will too. So have a good
All
week. We'll
right.
talk to
We'll
you
get
Friday.
back to the hospital.
Okay. All right. Bye.
Okay. Bye.